My name is Thomas Røhme, and I'm partner at Base, and I'm responsible for innovation and sales in our data science and product development area. And my background is that I've been working with, you could say, data and IT in life science companies for the past 20 years or so, and still do it at our customers. And with me, I have Peter.
Yeah, so my name is Peter. I'm a data scientist turned manager. I don't quite have the 20 years of experience that Thomas have, but I've been but I've been at Base for the past 3 years now, and primarily taking part in our product development and data science sphere of influence, let's say. So welcome all listening in online. Yeah, I hope you enjoy.
And we love questions. We hope that you will, while you listen, you will add all your questions to the chat, and then we will ensure that we have time to answer them after this presentation. And I would think we would spend around 40-50 minutes on the presentation, so there should be good time to answer some questions afterwards. So with that being said, let's jump into it. We will start by saying just a few words about us. We are a life science business and technology consulting company. We work in the intersection between understanding pharma, because that's all we do. We only work for life science companies. And we are consultants, and then we also work a lot with technology. And where those three meet, that is where you typically find us. And we have been growing quite a lot the last recent years, and we're now present in 6 countries here in Europe, headquartered in Denmark, and we are around 170 people and still growing. And I think one important thing to mention is that we are partnership driven. We have close partnerships with a lot of the big systems that we find in this industry. That's Viva, IQVIA, Salesforce, etc. But also with the various cloud platforms that are really important to us in the work that we are doing. That would be like AWS and Google Cloud and Microsoft Azure, which is the fundament for a lot of the work we do in the advanced analytics space. So just framing this discussion a little bit, and maybe also what we think is important when we talk about advanced analytics. The way that we see it often talked about is that it's something very complex and something involving a million moving parts and also slightly mysterious. We don't really buy into that necessarily, because when we talk with our customers, what they really need is simple tools that can be used by their users and that provide real value and solves problems. And that goes for any IT, and it especially goes for advanced analytics. So the way that we would like to see, you could say, advanced analytics talked about is in a much more practical sense. We see this as a valuable tool that can solve real challenges. We also acknowledge that there is a lot of stuff that's more advanced and belongs in this mysterious space. But we think a good idea when we talk about this is to start with what is really needed. And that's hopefully what we'll be able to share with you today. And just to start off with something concrete, we brought a few cases, and then we will use them to talk a little bit about how you actually get started on this analytics journey. So this is a case that we have done for one of our customers. They have the same issue that all their peers have, that during a submission, they receive a lot of questions from the different authorities. And there is often a deadline that you have to answer these questions in a fairly short time. And finding the answers and ensuring that you find the same answer the next time you get the same question is really complicated. Of course, you have the search functions in the various content management systems where the data is typically stored, but often people tend to have Excel sheets, etc., with the right links to the right documents and answers in order to solve this, because the time is typically short. So what we set out to do was to find a smarter way to do this by using you could say advanced analytics, in this case NLP, which is, you could say, AI for words. So what we set up was a simple solution, at least on when you explain it. Of course, it's a little bit more advanced when you dive into it, that automatically extract all the relevant information from, in this case, Vault. It could be another source, put it into our AWS data lake, and then on top of that, we built a search engine that could search into, you could say, the content from Vault, but using a way more superior search engine based on NLP. And that's, you could say, enables people to find the relevant content when they get a question from the authorities. And all the benefits from this is, I mean, obviously you can find your answers much faster, but since you now have a better way of looking into what are we normally answering to this type of question, then you can make better strategies when you prepare your documentation to authorities. You can give consistent answers, so you don't give the same different answers to FDA, for example, depending on what product you're looking at. And it's also way easier to get onboarded into a new area because you can find content. You're a little bit less dependent on finding the right person. So here we see, you could say, real value in the sense that it's an actual problem that, you know, is being solved by using AI in a very concrete way. And this is a nice example, we think, of a way where these new technologies make a lot of sense. And that we have built into what you would say our own product that we call Base Inquire. And really what it does is that you can take any source. Now we talked about Vault before, it can also be IQVIA. It's basically any cloud platform. And then you implement this search functionality. So now we talked about one use case for it, but obviously finding documents or finding the right content you need is a typical challenge. And this is a good example of where you know, modern advanced analytics can give a practical advantage. So that was one example. Passing it on to you, Peter, to give another one.
Yeah, so the next example here is what we like to call our content-based classification models. So sort of to set the scene here again, the challenge here is that a lot of the times we see our clients and also ourselves getting a lot of new data and a lot of new documents into their systems. And this can be derived from a different number of sources. It can be from CROs. It can be because you do a lot of mergers and acquisitions. But it can also just be a lot of documents that are procured on a daily basis through, you know, your daily operations. So the challenge here is that there is often a lot of requirements in your content management systems for what makes a document or a data point valid for entry, right? So you will have the requirements for, maybe you need to classify the document, what kind of type is it? Maybe there is associated metadata like the study of the document or the country or the site. And manually entering this data can be quite time consuming when this is done at scale. So the solution to this is to use machine learning and actually build classifications models to do this for you automatically. And these models can then be integrated into a migration pipeline or sort of an operationalized piece of software for your end users to upload your documents. So what this might look like is something like this. And this is, of course, an oversimplified example, but you might have some classified data already that you can use to actually train and validate one of these models. And then this model can be used for all new data coming in that is in some sort of unstructured or unclassified format. And then you can load that directly into your target system. Again, we're just using Vault here as an example. So what we did for this specific use case is that we made a proof of concept. This proof of concept involved a drag and drop like interface where the end users can throw in a document, and that will then start up an AI-enabled pipeline where it will associate the metadata and the document classification. The value of this is that you get sort of a streamlined way of enriching your metadata because you don't rely on humans to do it anymore, right? So there is no longer a difference between how one department might classify your documents or associate the metadata because you're using a model across your organization, right? So you have higher consistency and higher quality. So how this would work is that you have your assets, you load them into the solution, they tag the metadata and the classifications. You then get an optional user review and sign off, and then the documents are loaded directly into the target systems. So if we just look at that in a little bit more detail, you will have a login page. This can be set up, with your single sign-on, and you can drag and drop your documents. You review the metadata. If there are any warnings, or let's say you set a confidence threshold for your model, then you can flag those warnings or the low confidence classifications for review, and then it's loaded into the system. Another way that this can be used is as a cornerstone in what we like to call migration factories. So this is if you have ongoing data coming in from CROs or mergers and acquisitions, then you can have a scoping algorithm that targets it for your different document management systems. And then for each of those systems, you might have a classification model as well. You can also use it to construct what we call mapping rules and also to validate those, but we won't go into too much detail about that.
Just have a quick question. What does this replace? I mean, how much of a work effort from our customers does this actually remove?
Yeah, I mean, that's a really good question. So when we're talking about incoming data from CROs and mergers and acquisitions, the major effort driver here is the construction of these mapping rules, actually. So it is to define how we move data from one model, from one system into the new model. So this has immense value because that can take months to create these rules. And if you actually have a model like this or a pipeline, then it's instantaneous, because then you have already set yourself up. You have already trained the model on your existing data in your existing system, and that basically enables you to do it instantly. So in this case, it can be quite a lot of effort reduced.
Right.
So this is quite technical. I won't go into detail with this, but this is just to say that when we actually create these sorts of models, we do it using best practice. And we do it using state of the art and recommendations from some of the key players in these industries. So this flowchart here is created by Google. We do not necessarily want to compete with the data scientists and the data engineers at Google. So what we do is that we take the best practice that they define, and then we use that when we implement our stuff. And this is also just an example of what the proof of concept then ended up looking like. You can see that we can drag and drop in here, and we get some suggested classifications for our models, or for our documents. Sorry. Yeah.
Thank you, Peter. But it's not that everything here is a dance on roses, as we say in Denmark. There is, of course, also a lot of learnings in working with advanced analytics, and it's not necessarily all good ideas that we have been working with that actually turned into something useful. And we have tried to waste both hours and promises without it leading to something useful. And we would like to share some learnings we had from that. And it's good to start with an example that we once did. We worked with patents from one of our customers. Patents are obviously really important for a life science company, and being able to store and classify them correctly is really important. So what we set out to do was to build an AI way of doing this that could classify documents you could say automatically as they came in. And that's both desirable. I mean, it's really important to have this happening correctly, and it's feasible. We ended up having a plus 95% accuracy on the sorting, and the remaining 5% could then be handled by people. Then, of course, we set out to build this, because who doesn't want desirable and feasible things? But we didn't ask ourselves sufficiently was if it was valuable. The customer was very happy with our solution until the local VP concluded that it basically saves one FTE in Bangalore, which we discovered more or less after 5 to 6 months of intensive work on this. and obviously that stalled it. So this was never built. We are still happy for the project because we learned a lot from it. And what we learned was that it's immensely important when we work in this space that we build POCs, because POCs is where we really test if something works. We're going to come back to that. But and the reason for POCs is that there you actually have an opportunity for really seeing if it works and testing it with your users and gauging the real value. If you go straight to an MVP, you end up spending too much time on something that you actually haven't proven. So that was a key learning. Then another learning is operations. I think this is something we see across not only this project, but a lot of the projects where we work with this, that the eagerness to build is much higher than the eagerness to figure out how to live with it afterwards. So you end up building things, and then you end up in this like no man's country where who does it then belong to? Who can actually live with this afterwards? You have we also learned that stakeholders are very important to keep very close to the project. Of course, we prefer when we have when we have the requirements specified to just go home to our basement and sit there in our own comfort zone and building. But we need to really keep both management and users involved, again, to avoid ending up somewhere where it's not valuable anymore. And then we have to then also bias in, of course, you could say, to the overall learning we had, that don't build stuff that doesn't actually solve something or provides real value, because even though it's interesting and it fits your IT strategy, etc., things that doesn't provide the value will never be used. And that was what we learned here, among a lot of other things. And this is of course something we learned in this specific example. But when we look across our customers and see what they're working with, these type of learnings are there to a much higher extent than I guess we would like to have, but I think that's something to do with the maturity of working with this right now. I mean, even the latest examples we've been working with, they tend to all include some of these learnings still. So all that we have translated into our 5 principles of working with AI. So the first one, I've said it a few times, saying it again: solve real business challenges. You want to save cost, increase quality, or give you important insights. Kill and change what doesn't, or kill or change what doesn't provide this. If you realize that you are on your path to build something that doesn't really give value, go back, change or kill. And then co-create with people who actually benefit from that solution. And then comes a little bit of a new one we haven't talked about. We're going to talk about that later, that you really need a solid agile product development process where you keep, this continuous learning as part of your way of working. And again, don't build without knowing how to live with it afterwards. Any comments? No?
Sounds good.
Then how do you then get good ideas? I mean, where does all this start? That is something that we have worked with a lot of our customers with, and it's our, you could say, almost favorite type of assignments. It's very important that you develop your own method of figuring out good ideas and where you don't rush to solutions. We have been involved in a lot of workshops where you typically take a process area, you write it on a big whiteboard as we have here, and then you go through each steps and figure out where can data provide more value, where can we do something differently, and then you go and see if this new toolbox you have from AI can actually make a difference. And the reason why we always suggest that you start out broadly on this journey is that your first idea is seldomly the best one. So it's really about exploring. And that exploration phase is not something that we have invented. It's something that we have stolen with pride from design thinking, which is our, you could say, preferred toolbox that we go to when we work with a portfolio of use cases for our customers. You have to start somewhere with a lot of good ideas, but then you really need a structured process for being creative, meaning that how do you assess the good ideas if they actually work? how do you design them and conceptualize them in a way that you can make a prototype? You have to do that in a structured way and spend time actually getting the prototype out to your users, so you can do a business value assessment of it. Does it really provide the value that you have wanted it to do? And then you put it into your backlog for building, starting with MVPs and going into final products. And this is the method that can be used just for one use case you're working with, but it really starts making a lot of sense to work in this structured way once you get a lot of use cases to ensure that you kill those that doesn't really provide the value as early as you can. And you also stay in this creative mode, playing with use cases, building prototypes, trying them out, go and change. Because that is the way that you, as we are based on our experience, that you know, the fastest way can actually start having solutions out there that provide value. Yes.
Yeah, I think we also have an example by the end of this presentation about how fast you can actually get into this proof of concept part of the process.
Yeah, no, this is a question that we gotten earlier. We maybe could just take it now briefly. So how long would you say that it takes to go from a good idea to you actually have things in your backlog? Now we have a super fast example, but you know, based on our experience.
I mean, in terms of getting from your proof of concept or from your idea to your proof of concept, it of course depends on the use case. But if you have a well-defined data foundation and you actually have a platform where your data scientists and your data engineers can work, then you can start this very, very fast. And I would say that most proof of concepts can and should be built within 1 or 2 months.
Yes.
If not even sooner, and then you can test whether or not this proof of concept actually brings you any value before you move into the minimum viable product phase and the later stages of the development as well.
And the reason why it's so important to really think about how fast this can be done is that many IT projects, especially in the business that we are working in life science, they can take a very long time. I mean, we are typically part of IT projects that takes years to complete with big organizations, and this is in a way a different type of IT that sometimes is a challenge also for our customers, even internally, that you really have to saddle it a little bit differently the way you organize yourself around this, because the benefit here is in building things fast, trying them out, going back. So it does require a different type of work, different way of working, and also a different way of organizing yourself. And we actually think that a lot of our customers, the way they organize IT, will be more flexible to sort of accommodate this process. We actually start seeing it even in the places where they work safe. Where they are, customer to these huge programs that, they also try to enable this, faster way of working.
Cool.
Yes, but then I think I will hand it over to you,
yes,
Peter, and then give an example on how you then actually do it, the work tools that we use, give some transparency to that.
Yeah, thanks. Before this is sort of a practical guide in terms of how you set up your data foundation and this platform for you to work in. Of course, let's talk a little bit about the very high level benefits that AI actually deliver and why why you actually want this, right? So AI, I think the thing that all of us know is that AI can provide acceleration, right? So if you can develop AI or a model to do something that humans do already, then that probably means that the model can do it faster than the humans can. You also get accuracy, right? So this is, again, you remove the human element from the equation. You ensure that if you have a validated and tested model, then your accuracy will probably also be higher, and it will be homogeneous across your organization. And then lastly, you also have alleviation, right? So you lift the work from the humans into the model. So manual tasks that can be a high effort driver on the human side can be executed very, very fast using AI. And how we get there is then this data foundation, data access. That means you need to be able to provide access to this data to your data engineers and your data scientists and your solution architects who will actually build these use cases for you. And then you need the solution and innovation driven process that Thomas walked through before. So in terms of actually getting your data foundation, oh, sorry. Is it the wrong way? Sorry about that. So the first thing you need is, of course, you need some sort of strategic intent. So this is on organization level. You need some sort of IT strategy that is aligned with advanced analytics and AI.
And interestingly enough, I think all our customers actually have that.
Yeah. This is all the rave right now across all of our customers. So I think we are definitely moving into a place where our customers, even in the pharma industry, is becoming very mature in this space. Then what you do, you have your strategic intent, then you start actually exploring what you can do to improve your current processes with AI and advanced analytics. And it might turn out that what you want to do doesn't quite align with your IT strategy. And then you need to go back, and then you might need to change that in order to actually move into this space in the correct way. Then you develop your use cases from that. And when you then have your use cases, and this can be you can get these use cases based on the process that Thomas walked us through before, then you actually can build them into your platform, right? And if you don't have an existing platform, or if you don't have an existing data foundation, then you need to build it. So if we take a practical example of what a platform like this might look like, is something like this. And again, this is just an example. These platforms and these data foundations can take shape in a million different ways. This is one of them, and this is actually a quite simple one as well. So let's just walk through that rather quickly. First, we have our source. In this case, it's Viva Vault. This is, at this point, the industry standard for document management systems in the pharma industry. Then we have a data pipeline. This data pipeline is leveraging some of the services from AWS. In this case, we have some serverless compute using Lambda. We have some time-based triggers, and we have all of this monitored in CloudWatch. What this basically means in human language is that what this means is that you have data that is constantly up to date. So whenever you get new documents and new data in your content management system, this data pipeline will ensure that you always have the latest data available in your platform, or in your data lake in this case. So this data is put into the data lake. In this case, we have a bronze, silver, and gold level. You don't even need that. You can just do one tiered data lake. And then you have your EC2, which is basically just a computer, which is where your data scientists and your data engineers will access the data from. And so the benefit of using a setup like this is that you have complete data integrity. What this means is that you never actually touch any of the data in your source system. You never touch the data in your content management system. You only touch it after it has been copied to your data lake, where your data scientists can access the data from. Your data is always up to date, thanks to the data pipeline, and you have access control through the cloud provider. And often this will be done using what's called a VPC, so a virtual private cloud. And you also have the high availability and security that the cloud providers is known for in this day and age. So that was an example of what that might look like. When you then have that platform, and when you can develop your use cases in that platform, then you start engaging your organization. So this is the time where you deploy your proof of concept in your infrastructure, and then you engage the organization, you get feedback, and then you run this iterative process where you do constant refinement and improvement of your solutions. And then once your development has completed, so to speak, it never quite finishes, of course, but then you hand over to DevOps or operations. So this is where your solution actually have to live long term. And this is I think this is a key point to drive home, is that you need to think operations into the solution when you build it in the first place.
Yeah, and then I guess the way that you then live with it is that you continuously have processes in like the white boxes, and then you add to your your portfolio of solutions in your DevOps.
Yeah, exactly. All right, so the next one is how we sort of try to leverage this sort of data platform as well, and also to explain some of our, let's call them key points of how we actually drive this advanced analytics effort at our customers and also internally. So we have what we call the base component universe. This is also sort of the middleman between the content management systems and a target system or a solution. It doesn't necessarily have to be a source and target environment, but it can also just be a solution-driven solution. But here we have our components, we have pipelines, we have parsers, we have models, transformers, and different ways of validating them. And the idea here is that these components can be used across solutions, right? So if you have solutions that can leverage the same component, then you shouldn't build the components twice. You should only build them once, and then you can maintain them one place, and those components can then service multiple solutions. So if I have many use cases that use data from the vault, as I showed before, then we only want to develop one, let's call it state-of-the-art pipeline from the vault to our data lake, instead of developing it 100 times for 100 different use cases. So what this basically boils down to is that while we have what we call our market-leading connectors to many of these content management systems, we still use state-of-the-art services provided by the main cloud providers. So again, we don't want to necessarily compete with the machine learning engineers from GCP or AWS, but where we can differentiate is our connectors to the content management systems. And this also means that we use the generic AI and machine learning tooling like TensorFlow and PyTorch, and we also leverage the managed services in NLP and text and content analysis space, and without going into too much detail on that. Yeah, and I think that is the main point of this. Do you have anything to add on this one?
No, I mean, I can just make a short comment, is that in a way, building solutions such like this has never been easier, because you do have a lot of Lego bricks existing already. So the art is really to be able to do this efficiently, and of course have the right competences, who understand these different cloud models and what they have to offer. That's also one of the reasons why we, today it is possible to go from idea to POC in a fairly short time, if you build your own component universe and are able to draw and manage services in an efficient way.
Yeah, so essentially we don't want to reinvent the wheel. We simply use what is already existing if it can serve the purpose of our business case. And then the art of it is basically putting it together in the right way so that it solves a real life problem.
Yeah, and being able to maintain and continuously improve it.
Yeah. Mm-hmm. So the last example I want to give you here is in terms of the Agile product development. This is a very, very high level simplified, let's say, roadmap. But usually you have at the start of a project, you will have a lead identified or an idea formulated, and then if you actually want to chase this idea or chase this lead, then you have to get data and infrastructure to actually create something, and that is when you then move into a hackathon or a proof of concept phase. Then when you have a proof of concept, then you have a stop-go decision. Does this proof of concept actually make sense? Is this something that the end users want to use? Does it provide real business value, or is it just fancy? If the answer to any of those questions is that it actually does bring business value, then you move into your MVP phase. And at the end of that, you will deploy your solution to a broader audience. And then you will start this feedback loop where you get feedback from your end users, you iterate upon it, and then hopefully you get to a fully marketable or operational product. So a funny example that we had internally on this process was a very fast road to POC, and it looked something like this. So this is just a screenshot of a mail correspondence that we had internally. Our CEO identified a potential use case for something, or an idea or lead, basically. Then the same day, we contacted our lead developer. We asked if we had the necessary infrastructure and the necessary pipelines available to actually create a proof of concept of this. And then about 3-4 hours later, we actually had a working proof of concept that was hosted internally in our infrastructure. So you can move very fast if you have the prerequisite platform, basically, right? So in this case, if we didn't have our infrastructure set up, and if we didn't have the existing pipelines, this would have taken much longer. But because we did, we could accelerate really fast on this. So yeah, and I think that's actually it.
It is. We have a good time for questions. We have already received a few. So let's just jump straight to the first one here. Is the possibility of using an own server for the execution of some computationally intensive task contemplated? Example, to save cost or to test new versions of code?
Yeah, so if I understand this question correctly, this is a question regarding using an existing on-premise server, for instance, instead of hosting an EC2 for your computational tasks in the cloud. This is definitely possible. We like to use the cloud because from our point of view, it's much faster to spin up a virtual machine in the cloud as compared to configuring a bespoke server on premise, but you can definitely do that, but you lose out on some of the let's call them out of the box benefits of the cloud providers.
Yeah, and I think it's also, I mean, I think it's key to see this as a step towards maybe going on a cloud journey, since it does provide a lot of you could say advantages for really going on this AI journey. Then we have received the other question. How would you handle developing a MVP2 while possibly still doing minor developments for bug fixing on MVP1? So a new version, you could say, of the same thing you're working on. I think we actually believe we have instances of that already.
Yeah, definitely. I think what we try to do most often is that when we have an MVP, so the first MVP, let's say, and that is deployed somewhere, then it goes sort of into a, I don't want to call it LTS, long-term support, because it's not, this is an MVP, but it will go into sort of a support phase where it's only minor bug fixes being made. And then on let's say the back end of things, the development for the next MVP can be conducted. And when a certain number of features have been implemented in the MVP2, then you deploy that, and then you continue the feedback loop like that.
Yeah, and I also think that we again, because user feedback is so important, so what we have done in a low practical sense is that you can actually go in, if you are in the MVP1, you could say, users who know where that functionality can click somewhere, and then they actually enter into the new MVP and then try that out to keep this feedback coming back.
Yeah,
I hope that answered the question. Otherwise, please add some more comments. We have also received a question from one of our colleagues about how we actually validate this type of solutions. I mean, we work with the GXP data, and I know this is one of those areas where, in general, the industry is a little bit challenged.
Yeah, so I mean, in the advanced analytics and the AI space, validation of these kind of models are, one of the highest priorities right now. One of the concerns about AI is that it is black box technology. So it can be hard to understand why a certain output of a model is as it is. But this is a major focus point of the industry right now. So one of the ways that you can, and this is maybe a little bit too detailed, but there is technologies like SHAP values that can actually explain sort of the bias and the weights of some of these models. But more often than not, what we tend to do is that we validate the output of the model instead of the model itself. So that is sort of how we approach this.
Yes, and I also think that, I mean, working in the cloud with the opportunities that gives for automatic testing and for really understanding how your new configuration is really transparent, that gives a lot of big advantages also in the GXP perspective, because you are way more, I mean, when you do traditional testing, you know, you only test the things that you specify, but here everything is tested, and it's very easy to run, you could say, test report going through everything, figuring out that things are like they should be. So there is a lot of gains, you could say, also on the GXP front when you work with these modern cloud platforms.
I think maybe actually one thing that I want to add to this as well is that a lot of the time, the reason that validation is a concern is that some of these use cases will be used to actually change or modify or add data that is GXP, right? So, but there is also a lot of use cases where you don't necessarily change or modify any data, but you use it as a tool to improve existing business processes without changing the final outcome of the process.
So it's a decision support, you could say,
yes, right? Yeah, exactly.
Then we have received a question about how you actually then measure the potential business value of these type of solutions. That's we also have some colleagues giving questions here. And I could maybe add a comment to that. I mean, the value of solutions such as the ones that we saw earlier, they are really in how they're received by the end user. That's in our universe. That's also why, I mean, you can make a requirement specification, and then you can sort of, you know, put in some KPIs about, you know, how efficient this new tool should be. And that can, of course, lead to, then you can verify, was this the way that we wanted it to be? Does it function as we specified? But again, the real value is when people start using it. That's also why we need to get solutions out there, test the MVP, get feedback back correct, until you really see that it's actually being used out there and provides real value. And that requires a conversation with the business more than, you know, actual KPIs. Then we have received a question also from yours. Have you experienced any white box model-based solution where predictions can indeed be explained within the pharma industry?
This is a really good question. This does happen, and there do exist white box models in machine learning and AI as well. So what we would normally call a white box model would be something like a decision tree based model. These models you can actually do complete inference from, so you can directly you know, determine why an outcome was made or why a decision was made and not the other decision, let's say. So these provide 100% transparency, and you could also argue for more state-of-the-art type models like XGBoost. This is an extreme gradient boosting model. These can be inferred almost to a humanly comprehensible level by stuff like SHAP values. So these we would consider white box, and you can validate these actually you know, with human eyes as well.
And just to maybe have you seen actual examples of that with our customers?
Yeah, so what we have done is that we have used some of these decision tree models to create mapping rules, for instance. So right. more often than not, mapping rules will be based on, you know, a set of criteria, and then if those criteria are met, then you classify or enrich a piece of data in one way. the effort driver here is to determine what are the criteria. Right. But if you can use a decision tree model to create those criteria for you, then it accelerates the effort immensely, and it still makes it human readable, because it's still just criteria, right? And it's human readable criteria. So yeah, it does happen in real life as well.
Hope we answered the question. Otherwise, feel free to drop us a comment. And we already got a follow-up to our answer on the way to handle MVP2 developments. I'm just going to read it up because we only partly answered the question. So the main concern is how to handle MVP2 developments while still making changes to the MVP1 during what you call the LCS period. Do you have a framework for handling these in parallel, or do you make changes to MVP1 part of the MVP2 development cycles?
Yeah, so again, let's see if I understand correctly. So you want to do development in parallel here. So this is basically a question about version control and when you deploy your changes. So if you have an MVP1 that is live, you can still make changes in the repository that hosts the solution of MVP1, and then have a branch for your MVP2 development running in parallel to that. What Thomas mentioned before is that we have actually done quite a combination of the two, where you have your MVP1 live, you continue doing small iterations on MVP1, and then we deploy MVP2 on the side of that. So it's essentially two different solutions, but from an endpoint or end user perspective, both solutions are accessed through the same endpoint, let's say. So if the end user goes into the solution, they will be able to switch over to MVP2 just with the click of a button, and then we can sort of use that to gather feedback on MVP2 while MVP1 is still a live and operational solution, so to speak. But in terms of the version control and the development from a low practicality point of view, this is just a manner of splitting the development branches apart, and then do the development of MVP2 in one branch and MVP1 in another branch.
Thanks a lot, Peter. And Karim, who asked the question, feel free to just drop us an email or something like that if you would like to have it, if you have more questions about this. Do we have any more questions from the audience? I'm receiving a shake head. I'm looking at my little list here. We also addressed the questions that we have received from colleagues. So I guess should we give people 10 minutes back to and we'll say thank you.
We can give them 1 minute to write any questions, and then otherwise we give time back.
Yeah, and again, I can maybe say that it's been a pleasure, and I really it's something that we care a lot about. So if you have any questions, then you're always welcome to reach out to me or Peter. We have our emails on the screen. There is no more questions. Thank you for today, and wish you all a good day. And yeah, that concludes the session.
Yeah. Hope it was valuable. Thanks.
Thanks. Bye.